Hello everyone, welcome to our series of webinars. My name is Daniel and I'm going to talk to you about scalable access control. As I said, my name is Daniel. I work as an identity specialist at Curity, and I spend my days working with our customers deploying secure API platforms and teaching them how to use our product in the best way. And I'm trying to spread my knowledge on API security and OAuth and OpenID Connect in general. So I'm going to talk to you about today is mostly about access control in an API platform and how we can express that using claims and scopes. And one tool that we usually use when deploying these types of platforms is the phantom token flows. I'm going to show you how that works. And later, I'm going to show you a bit of an example using the online OAuth playground we built called OAuth Tools. So let's dive into it. So how do we express permissions? What are permissions in an API landscape? So we can roughly define permissions as a way to describe what a client or a client application can do at a certain situation, combined with what a user can do at a certain situation. And when we want to make these permissions travel over a network, we can use the tokens, the access tokens used for authorizing you to access APIs as the information bearer to move those types of permissions from one system to another. And as I said, there are several different types of permissions. And in OAuth, when we talk about permissions, we usually talk about the scope parameter. The scope parameter is defined in core OAuth as a static string that defines what you're allowed to do with the current token. This static string has to be known by both the client and the API, but also the OAuth server. And as you can see in my example, there are list releases that would tell us that this token is allowed to list the available releases at an API of some sort. And this makes sense if it's only one API. We can have several scopes. We can have the list releases scope, we can have add release scope, and we can have delete release scope. And there aren't that many scopes, so it makes it quite easy to handle. We have maybe 4 or 5 scopes, and we can distribute them to APIs and OAuth servers and clients and manage it quite okay. Problem starts to hit when we have created about 10 or 20 or even 100 APIs. If we have 4 or 5 scopes for each API, that would mean that we have 400 or 500 types of scopes, and then it starts to get harder to maintain them all. And this is what we usually call a scope explosion. And to mitigate against a scope explosion, we can start sorting scopes into structures, or make them into URIs, or even having a scope being a JSON document. Things like that is types of thing that we have seen. For instance, the hierarchical scope, where in this example we have 3 different products, and each line is a scope of its own, where the longest one, the first one, for example, the product 1, sub area 1, feature 1, is a very specific scope. As of this product 2 is a much broader. And in product 2, that means that we have implicit scopes that's below the product 2 in hierarchy. So product sub area feature 1 means exact this operation, and product 2 means all operations for all sub areas under product 2. This could mean that we can lower the amount of scopes, but we still have a scope that is tied to a specific feature. And every time we update a feature, we might need to update the OAuth server to set up new scopes. Another type of scope that usually leads to a scope explosion is the resource URI type of scope, where a scope is the full and complete URI of the API you're allowed to call with this token. So for instance, the accounts part there would say that I have access to the accounts API. In this example doesn't say if that means that I can list all accounts, if I can add accounts, or if I can list my account or every account. So that might need some other URI, like the payments one, giving me the possibility to do hosts to payments. And here we go into the same type of thing with the static string, with the list releases, that now we need multiple URIs for each operation that's possible to do on an API, which probably leads to scope explosions. And another type of scope we've seen are the prefix scopes, where this scope consists of two different things. So the payments colon is the actual scope, and the string that comes after it is an ID. This is often used in transactional OAuth, where you need a token to perform a specific operation. Let's say a payment. I want to authorize that my third-party application can transfer some money on my account to another account. If we had only these static strings, then the client asking for the payment scopes would mean I would authorize all future payments, since I've already got access to the payment scope. But using this prefix scope mean that I authorize the use for, or I grant the client to be able to perform this specific ID of my payment. So the next time when I'm doing another payment, there will be a new ID and I will be asked the question again. This ID can then be put into tokens and used in authorization decisions later on, further down the APIs. This doesn't limit the amount of scopes, but it's just another technique of using scopes. So to summarize what I think about scopes is that you should keep the scope count at a minimum, because they are hard to manage. And if we have a lot of different scopes, it's hard to communicate between the different players in an environment on what scopes are available for every client and things like that. They're hard to maintain. So since we need a very granular access decision model, scopes is one tool and a good tool, but it can't be the full story. We need to mix in a bit of the user permissions. So a client could be allowed to access a resource like the list releases API, but the API only is allowed to give away the data to users that are part of a certain group. So in that case, we must now look at two things. We need to look at the scope parameter, saying that the client has gotten the scope list releases, but we also need to look at some other claims like groups. Daniel is part of the group developers, so he is allowed to give away this data to the client. So the union of these user permission, the claims and the scopes are the actual permissions of this token. So, and when I say claims, as we can see, they're mostly attributes about a user. Claims are attributes that are asserted by a party that can trust. So in this case, the OAuth server asserts that Daniel is a part of the group developers. So it claims that Daniel is part of the group. So everything in a token that's signed by a trusted party is a claim. Yes. There might be situations where you want to be able to allow the client to request certain claims at different times. And OpenID has one idea on how to request user claims, where they put claims into groups and they tie this group into a scope. So when you are running OpenID and you request the scope profile, that would mean you will get an access token with the scope profile, but you will also get the ID token with a certain amount of claims that is tied to the profile scope. In my example there, I got the preferred username and given name and family name, but there's a full list of claims that goes with the profile scope, like address and email address and verified phone number and things like that. But basically my full user profile will be inserted as claims into the token. This is a pretty good model, I think, to be able to get this certain claims at in a token exactly when I need it. So in this token, I wanted the full profile, but another token, I just want the email. I can ask for the email scope and I get those types of claims. In OAuth, this notion doesn't exist. This is entirely a OpenID thing, and therefore there's also only defined for identity data. And there's not about any client data or anything like that, and also they're all predefined. In Curity, we like this idea, and so we took it to OAuth as well. So in Curity we can define scope groups that are custom. So in my case, where I have a client that is allowed to ask for the list releases scope, it's also configured to give me the groups and department claims in my token. So in this way, we can set up and we can allow clients to ask for the exact power of the token it needs right now. So for certain requests, it might only need the subject of the user, but for another one, it needs a much more powerful token, and we can then allow you to ask for that token and use it for your API. So to summarize this, to be able to keep this scope count low and don't get this scope explosion where we have hundreds and hundreds of scopes to maintain, we can combine the use of scopes with claims. So this is just one example, and this is just client permissions, but instead of having payments scopes for all the different operations, we can have one payments scope and then add in a claim for what this client is allowed to do. So this client is allowed to do both list payments and create a payment, but perhaps not allowed to delete payments or things like that. And the union of these two parameters or claims is then the full permission of this client. And then when we combine it with user claims, we get even more granular access control. Yes, let's do more. So next, we need to look at it a little bit on how we then use this data and enforce it. to make it into actual access control and just not permission descriptions. And we usually do this by layering the model, where we first start with something coarse-grained that's just more or less filtering requests. And the further down the line we go, we can do much more finer grained access control. And finally, when we get to the actual data, we should have access to the full policy when we know exactly what is going to be the result of this request. There we can do the last bit of access decision, authorization decision. But first, in this model, we have a client to the left that has been issued a token with the scope of list releases for the user, Daniel. We have in the middle the OAuth server and the API gateway, and the API that is the actual list releases API. So in the API gateway, we have the policy that to access the API list releases, the token needs to be valid and it needs to have at least the scope list releases. So if it has that, it passes the coarse-grained access control, and you're now allowed to pass the request further. And in this example, we only have one step further down and we get to the actual API, the actual data of the things. But the API has now access to the full policy and knows what's going to happen. So before it can give away the data, it needs to also check that the user is allowed to give away this data to the client. So in this case, we check that Daniel is part of the developers group, which is true. And then the API can say, nice, we have all the data we need. The authorization decision is okay. We return the data back to the client. And in that case, we have divided the decision making. We offload the API a little bit so that it won't get a lot of invalid requests. And we have been keeping out the rules in the API gateway to a minimum. So we don't have to have all of this logic in both API gateway and an API. But what about PII? So in my examples, I had a bunch of the information floating around that may be not that sensitive, but at least it said my name in it. And we need to hide those types of information for the players that don't need it or is not allowed to see it. So usually what we do is we don't issue clear text tokens. We issue opaque tokens, which are random strings, and no one can really get any data out from it except the OAuth server. So the OAuth server issues the random string and the client gets it and they won't get any data from it, and neither does an attacker. So if an attacker steals this, can probably use it, but it will not at least see what the contents of this token is. So when this token is sent for the API, the same goes for the API. The API doesn't know anything about it, so it does have to ask the OAuth server for what data comes with this token, and we'll get back a response, and we'll say that the token is valid and this is the data that comes with it. So the API can now do its authorization decision and return the data if it's allowed to. So we've hidden the data from the client, but we've introduced unnecessary requests, perhaps, for the APIs. And it doesn't really make for a scalable model, since now all APIs in our platform needs to ask the OAuth server each time it gets a request, what is this token? So that's where phantom token flow comes in, which is a phantom token flow is not really a standard. It's an implementation of different standards. And it's a pattern that we use at all of our customers, basically, to be able to do just this. We deliver the data to the APIs in a secure manner, and we hide the data from the players that shouldn't have it. So it works like this. And the opaque token is issued for the client, still no data. And the token is sent for the API, but it's intercepted by the API gateway. The API gateway then introspects this token and get back to the data that belongs with it. But this is not the regular introspection response. This is a JOT, a JSON web token, signed JSON document that is signed with the private key of the OAuth server by Curity. And this token is then passed on to the API. The API can then validate this token using the public key of Curity. And then when the signature has passed, it can use all the claims inside the token to create its authorization decision. And well, it looks something like this. So now we have on the left evil internet side, we have a opaque token with no data. On the right hand side, we have a by value token, a JOT, with all the data. APIs can validate that these tokens are coming from a trusted source, they're still valid, and it's issued by Curity, and can take all the data from it and create its authorization decision. Also, a benefit of having the API gateway in the middle means that it can, for the duration of the token, cache the relationship between the opaque token and the value token. So it makes for a lot less chatty protocol. So that's it for my slides, I guess. But I wanted to jump into our OAuth tools and show you a bit on how this works. So I have in OAuth tools, I've done some preparations, I think. Yes, I have. But let's start over. So OAuth tools is a fully fledged OpenID and OAuth client. It is a generic one that can be used to any OAuth server, not just Curity. And it's very complete. It implements a lot of different standards, and it's a playground that you can use to test your OAuth server and test your clients and learn how these flows work. And to start, you need an environment to run this with. On this cryptic URL, I have my temporarily local environment that has the issue string of that. This ends with a tilde. But in OAuth and OpenID, they defined the metadata documents. It's in the wrong screen. So let's do like that. Sorry about that. But we now have OAuth tools up. I have a clean environment. I cleaned it while you weren't looking. So in OAuth and OpenID Connect, it's defined a discovery specification that says that the issuer of the OAuth tokens should be a URI, and under that URI on a specific endpoint should the metadata of that server be available. If I press discover here, OAuth tools can find all the information about my OAuth server. It has all the endpoints and whatever authentication methods and scopes and claims we can ask this OAuth server for, and all the keys we need to be able to validate tokens that comes with this, and things like that. Only thing we don't have yet is a client ID to use. And I created one in Curity. I created a webinar client that's allowed to use CodeFlow. And I also created a gateway client to use to emulate the API gateway. It's allowed to do introspection. So let's name this so we can recognize it later. So we're back to the basic page of OAuth tools. Let's make this full screen. So this, we have now an environment tab with our webinar, and to the left we can do start flows. So let's start a code flow. And we can here have all the parameters available for the OAuth requests. And if we select the environments, we should have the clients we had this created. We saw only the webinar client because that's the only one that's allowed to do code flow. We can now select what scopes we want to ask for, and let's select the list releases we did before. And we can fiddle around with all the OAuth parameters if we want to, but if you just make this is the request that will be made if I press run. So that I press run, and I'd be directed to my OAuth server, and I need to authenticate. Let's see if I remember the password. I did. So I got redirected back to OAuth tools, and I received a code to be able to switch this towards a token. So that's next time I'll auto redeem it. But when I changed it, I got an access token and I got a refresh token. So if we remember my slide with the phantom token flow, we are now on the left-hand side. We are the client, and we got an access token that's an OPAC token. This OPAC token doesn't mean much for us, but we send it anyway. We pretend now we send it for an API. And the next step that would happen would be that the API gateway needs to introspect this token. So let's start a introspection flow. Here I have the webinar enabled, and I can select the gateway client. I can select the issued token there or paste one in. So an introspection call looks like this curl here, where I can just press the introspect to make this request. So I've introspected my access token. I just did. I saw that the subject was Daniel. I was the one to authenticate. And I also got some claims describing the validity of this token, the issue that and when it expires, and the issuer of the token, but also got those claims that belong to my list releases scope. So I got which groups I'm in, and I got the scope list releases, and I also, yeah, the department I work at. So this is the data that comes with the token, but this is not the actual token. This is just an introspection response, which is the JSON. And we said that we needed a token to be able to pass it on for the API. So if you're using Curity, you can add on the accept application JOT header and do introspection again with the same token. And you will, instead of this response, you will receive a JOT. And to see what this JOT contains, we can start a new flow, which is decode JOT. And we will paste the, or not, there. When we paste this in, it's decoded for us. And we can see that it consists of 3 parts. First, the blue part is the header. The orange part is the payload, and the green part is the signature. The header describes how this token is signed, and also says what key it was used to sign this token. The payload is, of course, the claims from this token. So we can see Daniel 1, and we have the groups and department claim in there. It also says the purpose of this token is an access token. And since we have the issuer, OAuth tools could find the key that was used, and use this to actually validate the signature of this token. So we can trust everything that comes in here because we know that we trust the source of this and no one has tampered with it. So this OAuth tools is a very useful tool. It's a very complete OAuth playground. So I encourage you to use it and try it out and run it against your OAuth server and learn how all those different flows are working. I showed you a few, but there's 9 different flows currently, and we are still developing, so things are happening here still. Everything here happens in your browser and stays in your browser. We don't store anything on server side. And the only thing we needed, the OAuth tools needs to be able to reach your OAuth server. So in my case, I used ngrok to do that. Yeah, so that's it. So let's switch back to my PowerPoint. Hopefully. There it is. And some parting words. In October, there's a Nordic APIs conference coming up in Stockholm. And Curity is going to be there. Me and Travis and Jakob is going to host some sessions, and we have workshops available. So me and my colleague Jakob is going to do OAuth and OpenID Connect in practice, where we will talk a little bit about things I said in this webinar, but also all the basics of these protocols so that we can learn it in depth. And then Travis is going to hold an advanced OAuth and OpenID Connect workshop. So there are tickets available, so check out the website and sign up. So thank you for joining, and I hope to see you in October. Please get in touch on Twitter or email or anything, and just if you want to know more about Curity,